Joe is back from his break and tries to remember what he did before lunch. Right, he jotted down a formula for utility maximization. The utility for a decision maker, N, to go to a certain store location, I, equals V plus epsilon. The V we can observe. Epsilon, however, is an error term, describing utilities of attributes we have not observed, for example, the atmosphere in a store or a customer's daily activity plan. But if Joe can observe what epsilon actually is, how in the world does he derive epsilon then? All he can do is make an assumption. He assumes that epsilon follows an extreme value distribution and that epsilon store A is independent from epsilon store B, and so forth. With this assumption, he is able to derive a formula for choice probabilities, which looks like this. By making these assumptions and deriving this formula, he is arriving at the so-called multinomial Logit model. Great! Now he can finally calculate probabilities, right? Well, almost. He still needs to find values for V. Let V be the sum of the attributes of an alternative that we can observe, but all of the attributes come in different units. Therefore, we need some weights to transfer the attributes units into utility units. But these weights are more than just transformers. Think of it, we as individuals weigh attributes against each other while choosing one alternative over all the others. So maybe these weights do also provide some information about the trade-offs between attributes. That's why each attribute has its own weighing coefficient, beta. In mathematical terms, it would look something like this. Wow, it's getting late. Joe's afternoon caffeine fix starts to wear off, and he just can't wrap his head around the question, how in the world can he find values for all of the betas? That's a question for another day. Time for some much-needed sleep.